Graphing quadratic functions. For this section, we're going to be looking at quadratic functions and determining the axis of symmetry, the y-intercept, the vertex, and getting into the graphing of parabolas. So it says here, recall that a y-intercept is the y-coordinate of the point where a graph intersects the y-axis. The x-coordinate of this point is always 0 for a quadratic function written in the form of y equals ax squared plus bx plus c. When x equals 0, y equals c. So the y-intercept of a quadratic function is c. So using our quadratic formula, when we're working with the y-intercept, the y-intercept is representing your c. So looking at this first example here, we have y equals x squared minus 2. Our c is the value -2. So my y-intercept, where my parabola, my graph crosses the y-axis, is at my c value there, -2. The next equation, we have y equals x squared minus 4x plus 4. Looking at our c, value of 4, the parabola is going to cross the y-axis at the value 4. Last one here, we have y equals -2x squared minus 6x minus 3. A -3 is my c value, which is representing my y-intercept, which crosses the y-axis at the value -3. So we're going to do some examples looking at graphing quadratic functions. Before we get into some examples, there are a few steps you need to follow to help you solve these problems. So steps to follow in order to graph quadratic functions. Again, quadratic function is in the form of y equals ax squared plus bx plus c. Step 1, we're going to find the axis of symmetry using the formula -b over 2 times a. We then are going to find the vertex. Our third step, we're going to find the y-intercept, which is that c in the equation. Then we're going to find 2 more points that would fall on the graph. The 2 points would be on the same side of the axis of symmetry as the point containing the y-intercept. So we're going to look at some examples of this. Here we go. We want to graph this quadratic function. So we have y equals 2x squared plus 6x plus 2, and the steps are going to walk you through how to solve this. So for our first step, we're going to find the axis of symmetry using the formula -b over 2 times a. So my b is 6, my a is 2, so it's -b 6 divided by 2 times 2. That simplifies to 6 over 4, which becomes -1.5. That's going to represent my axis of symmetry. My second step, I now am going to find the vertex. To find the vertex, since this is my axis of symmetry, my x, we're going to substitute -1.5 into the equation to find my y. So when I substitute -1.5 into the equation, we have to think of orders of operation. So we have -1.5 squared times 2, which gives me 4.5, minus 9, we got 9 by multiplying 6 times -1/2, plus my 2. When we simplify this, we get -2.5. So my vertex, my x is -1/2, my y is -2.5. After I found my axis of symmetry and my vertex, I now am going to write this in the form, or look at my original equation, y equals 2x squared plus 6x plus 2. Notice my 2 is my c, which represents your y-intercept. So the graph is going to cross the y-axis at 2. So I need to now pick 2 points that I can add in. I need to pick 2 points now for x to see if additional points fall on my graph. So I can let x equal 1 and x equal -1. So when I solve this, I can do y equals 2 times x is -1 squared plus 6 times -1 plus 2. -1 squared gives me 1, so 2 times 1 plus -6 plus 2. 2 times -6 gives me -4 plus 2, so my y is going to be -2. So I could have a point that falls at -1, -2. If I plug in now 1 for x, I could have y equals 2 times 1 squared plus 6 times 1 plus 2. 1 squared is 1, so 2 times 1 plus 6 plus 2. 2 plus 6 is 8 plus 2 is 10. So my second ordered pair that I can put on here is 1, 10. So this is just picking 2 additional points to graph. And when I'm done, let me erase this so you can see what the graph is going to look like. I then can graph my parabola. So this is what my graph is going to look like. The easiest way would to first start by plotting your vertex. So my vertex here is at the value -1.5, -2.5. Then I could graph my 2 points that I just solved for, letting x equal -1 and +1. And I can also graph the point 2 that falls on the y-axis. So here's my 2 that falls on the y-axis. Here's -1, -2, 1, 10, and I'm going to connect the points to continue to make my parabola graph. So notice there were 4 big steps involved with solving this. You need to show your work for each of these steps in order to graph the quadratic functions. Our second example here is a problem-solving application, so it is a word problem. It says the height in feet of a football that is kicked can be modeled by the function f of x. Remember, f of x is another way to state y equals -16x squared plus 64x, where x is the time in seconds after the ball is kicked. Find the football's maximum height and the time it takes the football to reach this height. We're then going to find how long the football is going to be in the air. So my first step, I first need to find my axis of symmetry. To do that, I'm going to use -b over 2 times a. Here's the equation we're going to be working with. -16x squared is my a, 64x is my b. Notice we don't have a value for c, so I'll get to that in a minute. So we get -b, so it's -64 over 2 times -16, and that will simplify into -64 over -32, 32, and that becomes 2. So this would be my axis of symmetry. Now my second step, I find my vertex. To find my vertex, this value is the axis of symmetry, or we think of as x. So I go back to look at my original equation, f of x, and we're plugging in now 2 for x, equals -16, x squared is going to be 2 squared, plus 64 times 2. When I simplify that down, I'm going to get -16 times oops, I forgot to write squared here. 2 squared is 4, negative 16 times 4 plus 128. Negative 16 times 4 gives me negative 64 plus 128. So my f of x or my y is going to equal 64. So now to write my vertex, it's going to be 2, 64, because my x is 2, my y is 64. Then I'm going to now find my step 3, we're going to find my y-intercept, which is, we're going to look at our c right here. Now the equation is f of x equals negative 16x squared plus 64. We don't have a c, so we just add a 0. So what is going to be my y-intercept? It's going to be 0. So my y-intercept equals 0. So my graph is going to cross the point at 0, 0. The next thing I can do is I can pick 2 other values or a few other values, plug it into the equation to solve. So let's choose, let x equal 1. This is my step 4. If we let x equal 1, we're going to plug it into the formula here. So we have f of x equals negative 16 times 1 squared plus 64 times 1. When I simplify that, 1 squared is 1, so negative 16 times 1 is negative 16, plus 64 times 1 is 64. So my answer is going to be negative 16 plus 64 is 48. So another point that will fall on this is going to be 1, 48. So when I go to graph this is going to be a very sketched graph here. What I can do is I can look at my vertex. Here's my graph. I can count. I'm going to count by 20s here since it's pretty big numbers here. My vertex is 2, 64. So I go on my x-axis to 2, I go up to 64, and I put my vertex. Notice my a is negative, so this is going to be my maximum point, but then my graph is also going to cross at this point 0, 0 based on finding my y-intercept. So here's my vertex, here's my y-intercept point. Whoops. And then I can just graph this based on my points here. Whoops. Here's my parabola. Sorry, my right click keeps coming up. After you're done graphing your parabola, it then asks, find the football's maximum height at the time it takes the football to reach this height. So what you would use is that vertex value, which is going to be 64. Whoops. Which is 64. And then what you're going to do is it says, then find how long the football is in the air. So to find how long the football's in the air, you're going to find zeros for your parabola, and looking at where the zeros are on the x-axis. My zeros here are going to be 2 and 4. So however long it took is going to be based on the zeros on this graph here. So 2 and 4.